Yeah, hi, here is the provision proposal report presentation. My presentation uh, title is experimental and numerical study for the combustion and shoot formation of the biojet field. My name is Shan Xiao and my supervisor is Dr. Tian Bo and Dr. James Jokes. Here is the context. My biojet field shoot project is focused on three parts. The first part is normally biojet field. The second part is PIV system. The third part is biojet field software, calculation software such as conflict code. So for the first part, we can say that the biojet field includes Fischer-Tropsch FT sciences using natural gas, coal, and linguistic biomass as feedstock. Hydro process of renewable material from plants such as pain and soil, grasses, and hydro process renewable jet HRG is made from using cooking oil, alcohol to jet ATJ, sugar to jet STJ are two of cooked oil are two of the chemical the methanol, ethanol, and methanol, and a long chain of different fatty-based alcohols. Hydro process enter and fatty XHEFA oil and fats from both plants and animals, including vegetables. This is the ratio of the smoke point for biojet fuel and jet fuel, such as HEFA over jet A, FT over jet A, or ATJ over jet A. One can see that HEFA has shoot points compared than FT and ATJ. Here is the shoot volume fraction profile along the flame center line for biojet fuel. Here is the NVPM emotion characteristic of aircraft gas turbine engine burning biojet fuel blinds. Here is the aromatic. The participate matter PM include aromatic as the formation of the first ring is circumvented aromatic form polycyclic aromatic hydrocarbon pH as pH formation is highly correlated to shoot formation. The aromatic has not a linear relation with carbon number. With the global jet NVPM motion US stories, the global jet PM mass motion US stories offer assignment on avenue biojet NVPM motion for the magnitude of NVPM mass motion. The aromatic hydrocarbon in fuel are critical NVPM processors. The aromatic free property of biojet fuel lead to NVPM mass and numerical motion reduction. And this is the high temperature shoot formation. The higher reactant temperature leads to higher shoot formation. Alkanes are more sensitive to the temperature change than alkanes. Shoot oxidation may be lowered by higher reactant temperature. Here is one same engine thrust and different fuel types. The same fuel types, different engine thrust. Here's ground idle condition using Jet A1 fuel has the highest fuel frequency. Here's the different sampling temperatures are denoted using different color. The second part I will describe that the particular imagine velocimetry PIV use Davis 10 software. Imager CX5 camera has a sensor resolution 2440 times 2040. Davis PIV kit have options to combine 64 times 64, 32 times 32, 16 times 13, and 8 times 8 pixels as an integration area. If we choose 32 times 32 pixels to form an integration area and want to cover a total probe value roughly 10 times 10 centimeter, laser belong class 4 laser device. Here's the calibration example. Here is the dirty for the measurement. The dirty is adjusted by altering the frame rate and consequently the laser repetition rate. Here is 32 times 32 pixels to form an integration area and want to cover a total probe volume roughly 10 times 10 centimeter. Here's the PIV integration. The common integration size for PIV is 32 times 32 pixels. The cross correlation process normally have 50% overlap. Each integration window has 10 to 8 to 10 particles. Here is the experiment setup for PIV. The PCI and Davis platform, frame grabber, camera, and signal generator also have the laser. It's 532 nanometer, 30 million joules per plus max. It also have the mirror and the tank and the matching liquid index. You can see this is an experiment picture for tank and pump for PIV. Here is a transmission ejection microscopy TEM image demonstrating the higher abundance and larger algebraic size of P85 left panel and various ground idle condition right panel. Here is why we choose conflict code. The maximum relative energy gas phase chemical species programming language Fortran 90 MPI requires an intercompiler. It also needs Linux workstation and should function in linear flame diffusion. Here is the lower real number conflict code. The result is same with experiment. Here is an alkane's flame. Flame speed at same temperature and pressure condition. Methane is the lowest flame speed. Ethane is the fastest. Here is the conjugate heat transfer CHT model. Conjugate heat transfer CHT is a mesh model in conflict code. CHT is implemented by the harmonic mean method to model the heat transfer between the field streams and solid field tubes. CHT is the model in air stream and field tub. Here is a no CHT model 1 and CHT model 2. CHT simulation means part of the field tubes is included in the computational domain. Here is the structure of polycyclic aromatic hydrocarbon pH. Here is the pH desorption is the presentation mechanism on the wings for the CHT model right hand side, and the left hand side is the hydrogen obstruction C2H2 addition HCA surface growth remain dominant on the wings for the no CHT models on the left hand side, and the no CHT model can improve its prediction by increase alpha. And should production lower sensitive to alpha can be explained by the difference in shoot formation mechanism on the wing. Here the left hand side is another CHT temperature mesh model. The right hand side is normal experiment shoot wing picture. We can see there's another example of C2H4 NH3 pH model using conflict code. We can see that it's included 149 species and 1376 reaction for the neokinetic model. The opposite flow flame model made by chemical software. One of the important amino field is N2 0. It can be determined the chemical effect of NH3 on the flame. The conflict code can also run the C2H4 NH3pH model. Here is another model called cricket model. Here is another mechanism called cricket mechanism, or 8,000 reaction for 250 species. The thermodynamic data for most species were obtained for this chemical thermodynamic database. All numerical simulations were performed with the open smoke code, small hydrocarbon space, alkanes, alnanes, large hydrocarbon spaces, linear and branded alkanes, N-niacin, N-decan, N-dodecan, isooctanic, calco alkanes, aromatic alcohols, and oxygenated species, carbon mixtures. Here is a shoot value fraction for numerical results. Use cricket model and experiment for 124 thermobenzene, 124 TMB, and N-propionbenzene PBZ. Here is a shoot detail use conflict code drawn by TechPlot. Here is some experiment shoot examples such as how to determine the shoot value fraction FV and primary particle diameter dp by laser induced incandescence, normally called LRI system. FV and dp also can measure the needs more than 500 times. Shoot temperature can be measured by separator shoot emulsion SSE technique. SE results 15% lower than those determined by TM. Flame temperature can be measured by rapid thermocouple insertion RTI apertures transmission electron microscopy TM image and Raman spectroscopy can be measured shoot particle images. Here are all three parts of my presentation, and now I will describe the future work plan. I will come to China UK Low Carbon College Shanghai Jiaotong University for the lab this semester. It may get some experiment shoot process result. It also will compare with the conflict code results, and I also will choose our design chemical kinetic mechanism like quick, such as choose quick or replace another mechanism. And in the conclusion, the biojet fields such as ATJ and HEFA or FTSPK have a field shoot value fraction because of low aromatic content. PIV is a technique that can measure field velocity, conflict code, and additional model can be measure biojet field.